Hello dear students, today we are going to discuss our new topic, that is line standard and end standard. As the name indicates, line standard and end standard. It is the standard that is related to the length. So first we will discuss the introduction part. So what is length? As we already know that the length is the unit of a dimension, that is the unit of length, breadth, height. So length may be measured as the distance between the 2 points, two lines, or as the distance between the two parallel surface. If you want to measure the distance from this point to this point, so this is also the length. If we measure the distance from this line to this line, so it is also the length. And if we measure the distance from this face to this face, then this is also the length. So we will discuss the length with the help of line standard and end standard. So for the direct measurement of linear dimension, it is having two standard, that is line standard and end standard. So first of all, we will discuss line standard. Line is what we call it as line when the length is measured as the distance between center of two engraved line. It is called as line standard. If we recall our previous lecture, I have explained you the standard meter. That is what 1 meter is defined as the distance between the two parallel lines that is engraved on platinum iridium alloy. So what we discuss in that, there are two parallel lines engraved on the platinum iridium rod, and the distance between these two parallel lines is considered to be 1 meter. So what is line standard? When the line is measured as a distance between centers of two engraved lines, so it is called as line standard. So both material standard, yard and meter, are the line standard. The most common example of line standard is our ruler with divisions as shown, lines marked on it. For example, like this, in this given figure, there are the lines which show the gap in between them, and this is the having the particular length in each division. So from one divisions to the next division, it is termed as one, and each division is subdivided into 10 divisions, that is 1 mm. Next, characteristics of line standard. So the first characteristic of line standard is scale can be accurately engraved, but engraved line themselves possesses some thickness and it does not possible to make measurement with high accuracy. As it is shown in the previous figure that this scale is made with the help of number of divisions, and each division is made up of some lines, and each line is having some thickness. So we cannot get 100% accuracy with the help of this ruler, because each line which is engraved on the ruler is having some thickness. So it is also consuming some part of the length. So it is not 100% accurate. Next is a scale is quick and easy to use over a wide range of measurement. As from our childhood we are using scale, so it is very quick and easy to understand and easy to measure the things with the help of scale. Third is the scale marking are not subjected to wear. As in this figure, these marking are not subjected to wear, but the corner edges of the scale get subjected to the wear. So however, the leading edge are subjected to wear. This part, this is the leading edge, this gets subjected to wear, and this may lead to undersize measurement. This happens due to the continuous use of the scale over the time. Fourth is a scale does not possesses a built-in datum which would allow easy scale alignment with the axis of measurement. This again result in undersizing. Let us suppose if we want to measure the distance between this line to this point to this point, so we will keep our scale on this point and we will easily get the length of this dimension. But there is no fixed datum for a scale, so we cannot fix that this is our datum for that scale. Next is fifth point, scale are subjected to parallax error. What is parallax error? I have already discussed in the previous lectures that whenever we have to take the dimension measurement in terms of the measurement in terms of the device in which some divisions are present, then we have to keep our vision in front of the division which we have to read. So this is called parallax error. Sixth is also the assistance of magnifying glass or microscope is required if sufficient accuracy is to be achieved. If the readability of the scale is not good, then we have to use the magnifying glass to increase the readability of the scale. So these are the characteristics of line standard. Next type of standard is end standard. End standard is what? End standard is the standard when the distance is measured between two parallel flat surfaces. Previously in the line standard, we will discuss that in the line standard, the distance between the two parallel lines. Now, what happened in end standard? End standard, we consider two faces that are parallel to each other, and the distance between these two parallel faces is measured, and this type of standard is called as end standard. For example, slip gauges, anvil of micrometer. So this is our micrometer, and these are the anvil of micrometer. So we will do the measurement between these two parallel faces. So that's why it is called as end standard. And this is the example of end standard. And this slip gauge, we will discuss slip gauge in detail in our coming lectures. But this is a slip gauge. This is a slip gauge. So let us consider this surface and the surface behind this surface. So the gap between these two surfaces is the distance. It is the work of slip gauge. It will only give you one dimension at a time. The end faces are hardened, lap, flat, and parallel to very high degree of accuracy. It is compulsory for the end standard that the flat surfaces must be parallel to each other and they are completely flat. For example, in case of anvil of micrometer, this is flat and this is also flat. So, and this is completely hardened. So the distance is measured between the two parallel flat surfaces with the help of end standard. Next is characteristics of end standard. First one is end standard are highly accurate and well suited for the measurement of close accuracy up to 0.005 mm. They can give the accuracy up to 0.0005 mm. And with the help of a scale, we can measure up to 0.02 mm. Second point is they are time consuming in use and prove only one dimension at a time. We have already discussed that in case of a micrometer, we will take only one measurement at a time. We cannot measure more than one dimension. So end standard is supposed to measure only one dimension at a time. Third point is end standard are subjected to wear on their measuring faces. For example, these are the measuring faces of micrometer. With respect to the time, they get subjected to wear. They get subjected to wear. Next is end standard have a built-in datum because their measuring faces are flat and parallel and can be positively located on the datum surface. For example, if we take example of anvil of micrometer, so these are parallel flat surfaces. So these itself form the datum for the measurement. In case of slip gauge, if these two surfaces are parallel to each other, so this, you can say that this is a standing slip gauge. Why it is standing? It is forming the datum for its measurement itself. So end standard is having a quality that it can provide the datum itself for the measurement. Next is they are not subjected to parallax error since they use developed on feel. Uh, by taking the example of micrometer anvil, we can see that by putting the object in between these two anvils, we can look, and according to the feel, we can take the measurement. That now the workpiece is completely fitted in between the anvils of the micrometer. Now we can take the measurement easy. So these are not subjected to parallax error. These and standard, but the scale can be subjected to parallax error, as scale is the line standard. Scale of the micrometer is a line standard, but the anvil of the micrometer is end standard. Next is group of slip gauges can be run to each other to build up a given size. Faulty ringing and careless use may lead to inaccurate result, because I have already told you in the second point that we can measure a single dimension with a single end standard. Now we have to club number of slip gauges to measure a given dimension. So they can be take the right reading if there is a property in the slip gauge that we have to run one slip gauge over the other, so they get stick to each other and fulfill the dimension which we need. We will discuss what is ringing and slip gauges in detail in the upcoming lectures. Now, what is the difference between line standard and end standard? So I have divided in terms of characteristics. First one is the principle. So what is the principle of line standard? Line standard is expressed as the distance between the two parallel lines, but in the end standard, length is expressed as the distance between the two parallel flat surfaces. Accuracy, it is limited up to the accuracy of plus minus 0.2 mm. As we see the scale, normal scale that we use in our day-to-day life, its accuracy is plus minus 0.2 mm. But the accuracy of end standard is 0.005 mm. It's 0.00030 are here, 5 mm. Ease and time of measurement. Line standard, that is the scale, is very easy and quick to use. And in end standard, we require a lot of skill and it is a time consuming process. As we see in the case of micrometer, by doing the practical, we require more than or near about 5 minutes for taking one reading, and which can be done with the help of scale in seconds. Effect of wear. In line standard, scale marking are not subjected to wear, but in end standard, the faces of the end standard get subjected to wear. Alignment. Alignment, it is not having any datum, so cannot be aligned with the axis of measurement, but they itself work as a datum, so therefore they can be aligned with the axis of measurement. Next is manufacturing and cost. Manufacturing and cost of line standard is easy because it is a scale. Cost is comparatively easy. Manufacturing is easy and cost is less as compared to the end standard. End standard manufacturing process is tedious and it requires a lot of money, and cost is also more. Next is error. As I have already told you that line standard are subjected to parallax error, but end standard are not subjected to parallax error. Examples of line standard are steel rule, and the example of end standard are slip gauges, end bar, micrometer anvil, vernier caliper jaws. These are the example of end standard. So here are this topic is completed, the line standard and end standard, and from the next lecture we will discuss linear measurement. Thank you so much.